Okay. So next to last section, okay, we got 9.3 and then 9.4 will be the last one. Okay. So almost finished. We don't have too terribly many more formulas to get through. And that's the downside of the financial part is it's mostly just formula after formula. Okay. They do get a little uglier in this section. And so this section and the next section are really why I suggest getting the calculator where you can see what you're typing in. So, because it really helps. It really helps. All right. Let's see. You may think anything we need to talk about? We don't really have too much. Oh no, we've already talked about test 3. Be on the 17th. One thing I will mention. So technically after Thanksgiving break, let me see what day that is. So after Thanksgiving break, that would be November 29th. So that'll be the day we review for the final. For anybody that wants to take the final exam, you'll know by then what your score will be. And then technically the 1st, December 1st, is a class day for us, but none of us will meet on that day. So if you don't have to take the final, you're done. That's right. Yeah. Yeah. So potentially next Wednesday is the last day if you're in a good spot. Okay, if you're happy with your grade there. Next Friday I'll do a Hawks Day. Probably nobody will come. That's okay. But anybody that wants to can come next Friday. And then we'll have Thanksgiving break, and then it'll just be getting ready for the final for anybody that needs to take the final. Not much left. Not much left. Okay. All right. So let's look at this section. In this section, we are focusing more on saving money. And we've talked about it a little bit. We're going to see some different ideas, different formulas. That's what it boils down to as far as the math. And a few different ideas here. So we kind of talked about interest from the point of view of being bad, that is extra money you have to pay if you borrow money. Okay. But if you're saving money or investing money, interest is a really good thing. So that's kind of our focus in this section. So we really have two types of saving that we do in life usually. We have like short-term goal saving, like I'm gonna save up for the next several months to put a down payment toward a car, that kind of saving. And then something you're probably not thinking about yet, but is saving more long-term, like after we get ready to retire. Okay, we need to have some savings there. So really, two philosophies on saving money there. We're going to look at some of each one. Okay. So look at our first formula. It looks a little bit scary. Okay. It's a present value formula, but all it is, we've really already seen this formula. It's just rearranged. Okay. Before, when we saw this thing, we said A, the amount of money we end up with, was our principal. And then when we're doing compound interest, we had the 1 plus R over N to the NT. So this is really the same formula. And all that's happened is we've taken this term and moved it over to the other side. So we've divided both sides by this set of parentheses. And instead of principal, we're calling it present value. That's how we use the formula in this form more. Okay. So It's really not too much more difficult to deal with in the calculator, because all we really have to do is calculate this part, and then we can take the top number and divide it by that answer. This one's not too bad yet. So all of the variables in here we've already seen. Remember, R is our interest rate over a year, APR, and we're gonna be given it as a percentage. We want to write it as a decimal. Okay. N's are compounding intervals we saw already. Okay, how many times a year we're compounding interest. T's time in years still. Okay. Here, A is the amount of money we want to end up with, our future value. And then PV, okay, would be our present value, how much money that is now. And so the idea of what we're dealing with this formula, we're thinking about if we invest this amount of money now, how much will it be in the future? Okay. At given a certain interest rate and period of time. Let's look at a problem where we use this thing. All right, so this one says State College predicts that in 18 years it'll take $150,000 to attend college for 4 years. And so we're thinking in the future, okay, we're going to need $150,000. Okay. Says Amber has a substantial amount of cash and wishes to save money for her newborn child's college fund. How much should Amber put aside in an account with an APR of 4% compounded monthly to have $150,000 in the account in 18 years? Okay. So we want to know how much money we should set aside today so that in 18 years it'll pay for college. Okay, it'll be $150,000. Okay. So let's get our numbers. So here T is going to be our time. It's going to be 18 years. That's how long we have to leave the money in our account. Our APR is 4%, so in our formula R, we have to change it to a decimal, so R will be 0.04. We're compounding monthly, so what should we use for N? How many months in a year? 12, so N will be 12. And then the amount of money we want to end up with, in this case, that's what we're calling A, future value. It's going to be $150,000. Okay. So we can plug into this thing. Here's our formula again. That's the amount we want to end up with divided by 1 plus R over N, the NT power. Okay. We want to end up with $150,000. Going to be invested in an account with an interest rate of 0.04%, compounded 12 times a year, so N is 12. And then we're leaving it in there for 18 years. Okay, let's see what we get out of that. The way I'm going to type it in is I'm going to do the bottom part, and that'll give me some number. I'm going to leave that number in my calculator, and then I'll do 150,000 divided by my previous answer. I've got a little A and S button on mine. Yours should have something similar. Okay, if you're writing down the answers you get, let's see what we get. So for the bottom part, 1 plus 0.04 divided by 12 raised to the 12 times 18 power. So it's 2 point something's when I get there. If you're gonna write the number down instead of just saving it in your calculator, you want to leave a whole bunch of decimal places, like 6 or 7. Okay? Because our final answer is going to be rounded to the nearest cent. Okay? So those decimal places can make a big impact. Okay, it can throw your answer way off if you drop too many decimal places. So So I'll do 150,000 divided by that number. End up with $73,100 and rounds to 31 cents. All right, yeah, so here, the way I type that part in, let me show you what I type in mine, I'll write it in blue when I type in. So for the bottom, I would do a parenthesis and then 1 plus 0.04 divided by 12, close parentheses. And then I'll do my little exponent button. Yours may look different. Mine actually just has an X with a blank box beside it. But and then in the exponent, I put 12 times 18. I do for the bottom. It's hard on a phone. Did you get 2 point something? Okay. Yeah, so I got, that's just the bottom part. That's not the final answer. And I got 2.0519748828, the whole thing that came up on my screen. And then we're doing 150,000 divided by that number. That gets us our final answer. Okay. So, what was her name? If Amber has $73,100.31 today, and she can invest that in this account that she's found, and it'll be ready with $150,000 in 18 years, her child to pay for college. Okay, questions here? You guys have calculator issues? The two big obstacles on doing these problems, okay? Knowing what number to put where in the formula. And we've seen several of them over and over, so that kind of helps. Like R's interest rate, you gotta change it to a decimal. N's how many times we're compounding per year, so we gotta kind of decode that. And then T's are time in years, so keep that there. And then the other thing that's a hurdle is being able to do it in your calculator. So on test day, what I want is I want to see this, where you plug the numbers into the formula, and then you can give me the number. Because if I let you just give me the number, it's really easy to make a mistake trying to type all of this mess in. So if I just let you give me that, I don't have much I can do for you. But if you give me this and this, and if this is wrong, I can go back and say, oh, they accidentally hit 17 instead of 18. So I can give them a bunch of credit, or most of the credit, something like that. Questions on that one? Okay. So generally they say inflation, right? So inflation is just how much cost of everything increases over time, right? So when your parents were driving around, gas did not cost $3 and whatever a gallon, right? It just naturally goes up over time, what we call inflation. Usually that's about 3%, what it averages out to be typically. It's about 3% per year. So the fact that she's put her money in an account that's getting 4% interest, I mean, it's not only going to keep up with inflation, I think it's going to grow a little bit. That's what we want. Okay. So if you have any family members that are like, that don't trust banks, okay? And then just take their cash and like hide it somewhere in the house or something. Maybe your family doesn't have anybody like that in it. They're missing out on interest. So then what's happening is that money's actually losing value because it's not keeping up with inflation. So if you take a $100 bill and hide it away and you go to get it out 20 years from now, that $100 bill is not going to buy the same amount of stuff as it would have 20 years in the past. Just something to think about. All right, let's go to the next one. Let's see. Same type of problem, it just gives us the numbers. Okay. It says how much should you deposit now in an account with an APR of 7% compounded monthly if you wish for the account to have a balance of $200,000 in 25 years. So how much is it going to cost us now if we want to end up with $200,000 in 25 years? Okay. So we need all of our numbers again. Let's see what we can find. So APR 7%. We change that to a decimal. R will be 0.07. $200,000 is the amount we want to end up with in the future. That's A in this case. We're going to leave our investment there for 25 years, so T is 25. And then the interest is compounded monthly. So what do we use for N again? Compounded monthly is 12. 12. Okay, so 200,000 divided by 1 plus 0.07 over 12, and all that's raised to the 12 times 25 power. Okay. Again, I'll do the bottom first. That was almost bad. That almost flew out toward one of y'all. That would be a tragic accident. Somebody got poked in the eye in class. That's really bad for a math accident. You normally don't hear about anything that violent. Okay, so all right, let's see. Do the bottom first. So 1 plus 0.07 divided by 12 raised to the 12 times 25 power. There, if you're doing yours individually and you want to check yourself, I get 5.725 something. And then we'll do 200,000 divided by that answer. And get $34,931 and it rounds to 95 cents. Okay. So not too bad. If I've got a little less than $35,000 I can invest today, and in 25 years it'll be $200,000. Okay. Now I know, you might think that never happened. You just got $35,000 laying around. So what you've got to think about, especially on like the last one where it said the mom had a significant amount of money and wanted to put part of it away to save for college. So real life for most people when this type of thing happens is if you get like an inheritance from a family member, or if you have some type of insurance settlement, or I guess you could be really lucky and win some money in the lottery or something like that. And that's what we're talking about. We've come into a lump sum of money and we want to invest part of it for the future. Questions on that one? Okay. That's future value. The next kind of type of investment, and that's way to save money that we're going to look at, is called an annuity. Okay. So all an annuity is where we're either making regular payments into an account over time, or it can work the other way also. You can receive regular payments out of an account over time. So speaking of winning the lottery, if you do win a bunch of money in the lottery, then or if you have like a big legal settlement, sometimes as well, it'll be set up this way. They'll give you an option on how you want to receive payment. So either they will give you a lump sum, that's give you the total, but that's usually at a reduced amount. So like if you win, I'll make the numbers easy. If you win $1 million in the lottery, they'll say, well, we can either give you $700,000 today before taxes, $700,000 today, or we can pay you $1,000 a month for the rest of your life. So they set up that way. And that would be an annuity where they're giving you payments on a regular basis. Here we're thinking about investing, so we're thinking about if we're taking and making payments into an investment. Okay? So maybe like every payday or every month, something like that, we have some amount of money we're putting into. So typically that's how some things like a 401k you might have heard of, retirement plan, those things as we work, we pay so much our paycheck into it and then end up with it when we get to retire. That's an annuity. So what we want to be able to do, we want to figure out if we want to end up with some future value, some amount of money in the future. How much should we pay in payments on a regular basis? So here we're going to think about how much should we pay a month usually, okay, to end up with that amount of money in the future. So this is a little more realistic in most situations, right? Normally we don't have a lump sum that we can invest. So this would be more typical. Okay? We're going to set aside some amount of money to pay every month to try to reach our goal. All right, so this form is a little bit messier. So PMT, that's the payment we're making. That's all one thing. That's PMT. And on the top, the 1 plus R over N to the NT, that's out of our compound interest formula. And then we're subtracting the 1. And then we're going to divide by our interest rate over our compounding interval. So usually what I do is I figure this part out, okay, the part with all the parentheses, and then multiply it by our payment. Let's look at one. So no really new variables in there except for that PMT. And the PMT, that's all one thing. And it's just short for payment. And then FV this time, they're just shortening future value. Future value. So let's look at a problem. One says Daigle begins placing $75 per month into an annuity savings plan when he begins receiving his first official paycheck in August 2014. The savings plan earns 2.5% APR compounded monthly. And we want to figure out two things here. And it does make it a little bit more interesting doing these two. A says figure out the amount of money that Daigle will personally put into the savings plan over 10 years. So how much is he actually depositing into the account? And then B says calculate the future value. So how much is it worth? And we want to do that in August 2024. So part A first. And part A is easy. We don't have to have a complicated formula. So don't overthink one if you see one like part A. Okay, it says he's putting $75 per month into the account. We just need to figure out how much that will be over 10 years. So for A, so 10 years times 12 months in a year, not months, months. It would be 120 months. So he's going to make 120 payments. So we just have 120 times his $75. His $75 per month he's putting in there. Okay. So over the 10 years, he will actually, out of his paycheck, put in $9,000. Okay. Part A. And then part B, we want to figure out what that total value of this account is going to be after 10 years. So, and part A gives us that it's 10 years. Okay. So I don't really know what's up with B, but B gives us August 2024. So we would just subtract 2024 minus 2014, it's 10 years, if it didn't give us this already. Okay, so T is going to be 10. 10 years. What else do we need to know? We need to know our payment, PMT, $75 a month. 2.5% APR means R, going to be 0.025. And then we're compounding monthly, so N is going to be 12 again. So let's fill into our formula. Sorry about that. On the B part, here's our formula again. And I'm not putting the brackets on top, they're not really necessary. They were just trying to make it extra clear what was going on. Okay, so PMT was $75 times 1 plus 0.025 was R. N was 12. And 10 years, so T was 10. Okay. So I'm going to do the top part of that first, my calculator. So I'm going to do a parenthesis 1 plus 0.025 divided by 12, close parenthesis, and raise that to the 12 times 10 power. I'm going to hit equal, and then I'm going to hit divided by parenthesis 0.025 divided by, is that supposed to be N on the bottom, right? Sorry, it's supposed to be 12. Divided by 12, not 10. Okay, so there, if you want to check yourself, I get 616.17 something. And then that's times 75. I get $46,212. And that's a little tough to round. It's 0.895, so it rounds up to 90 cents. Yep. Okay, so that'll make a big difference. Let me see if I may just not have said it. Let's see, 1 plus, Thank you for pointing that out. 0.025 divided by 12 raised to the 12 times 10 power minus 1. That's right. And then divided by 0.025 divided by 12. There I got 136.17 something times 75. Yeah. Oh, he's a little disappointed now. Thought he had $46,000 and he doesn't. He has $10,212.90. So he's personally paid in $9,000, but it's worth $10,212.90. That would typically be more impressive. That's why I wasn't like right away thinking I made a mistake on my number, but that's a low interest rate. 2.5% is pretty, if you're trying to make a long-term investment, 2.5% is pretty low. Again, you want 3% about to keep up with inflation. So. Questions on that one? Get calculator issues figured out if you had any. Don't have a calculator today, bring it Wednesday. Okay? You don't want the fact that you can't type it in your calculator and get the right number to be a reason why you miss one. Because all that takes is a little practice. You don't have to do anything too strenuous. Okay. Look at another one. This one's got a better interest rate. So. Get through all this. All right. This one says use the annuity formula to calculate the future value after 6 months of monthly $50 payments for an annuity savings plan having an APR of 12%. The only thing that's a little weird on this one, okay, is that we are only leaving it in there for 6 months. And remember, T is in years. So 6 months would be half of a year. Or as a decimal, T is going to be 0.5. Okay. $50 is going to be PMT. 12% tells us R is going to be 0.12. And we're making monthly payments, so you can think about the N being 12. It doesn't say specifically compounded monthly, but that's, we still use the monthly there. Okay. Then we fill into that monster. And again, you can tell I messed it up, right? So a little bit trickier to get everything right on the calculator. So we're making $50 payments. One plus 0.12 over 12 to the 12 times T, this time's 0.5. Minus 1, I'll remember this time. And then divided by 0.12 over 12. Here we go with our chore, typing this thing in. Okay, so 1 plus 0.12 divided by 12 raised to the 12 times 0.5 power minus 1. There I get 0.0615 something divided by 0.12 divided by 12 gives me 6.152 something times 50. Wait a minute. I got a weird number. No, I guess that's right. Okay, because we're only doing 6 months. So I got 307.60. So yeah, the why that comes out so weird is because we're only leaving it in there for 6 months. And so why I say it's weird is if you do $50 for 6 months, that's $300. So he's only making $7.60 interest here. Okay? That's because it's only in there for 6 months. The 0.5 was because it's 6 months and T's in years. So 0.5 years, half a year is 6 months. So that was the weird part on that one. Other questions on that one? The numbers are way more impressive when you leave it in there a long time. And because the longer you leave it in there, the faster it grows, remember? For the more payments you make, the longer you're making payments, the faster it grows. No other questions on that one? So here's thought. Okay. Try to get some applications out of it. Is it worth paying into an annuity if you're only going to leave it in there 6 months? Not really. Okay. The hassle of getting something like that set up for 6 months, to me, would not be worth $7.60. Okay. So short-term investment, savings account or something like that, just at the bank is fine. Okay. Even though savings accounts are not paying out much right now, maybe you'd end up with $301. Okay, what'd you lose? You lost $6, and you didn't have to hassle with all that paperwork. So, not a big deal. Okay. Annuities are better for long term. Okay. We'll get one more of these somewhere. Let's look at this one. Okay. This one's a better fit for an annuity type deal. Okay. It says at the age of 25, Angela starts an IRA, which is an individual retirement account, save for retirement. She deposits $200 into the account each month. Based on past performance of similar accounts, she expects to obtain an annual interest rate of 8%. Okay. If you talk to retirement people, when you start getting into the 8% range, you start kind of getting into the magic range of where you want to be. So most retirement investing type things, you're going to aim between 8 and 12%. Okay. More the better. Okay, more the better. All right. A says, how much money will Angela have saved upon retirement at the age of 65? Okay. So I guess first, how many years is that going to be? How do we figure that out? He's 25 now, he wants to retire at 65, so 40 years. Yeah, we just subtract 65 minus 25. The T is going to be 40. Okay. R going to be 0.08. Okay. Our payment is going to be $200. It's monthly. And it'll be 12. Okay. So we're ready. We're ready. So we can fill into our formula. Okay, so it's $200 per month times 1 plus 0.08 over 12. 12 times 40 power minus 1 all over 0.08 divided by 12. Let's see what we get there. So 1 plus 0.08 divided by 12, all raised to the 12 times 40 power. On that part, I get 24.27 something if you're working along. So minus 1, 23.27 something. Divided by parenthesis 0.08 divided by 12 gives me 3,491 point something, okay, times 200. It's me, all right, $698,201.57. So $200 a month for 40 years. Get you almost $700,000 there. B part, where this really becomes impressive, okay, hopefully, is compare the future value to the total amount Angela deposited. So to figure out how much she deposited over time, it's just $200 a month for 40 years. That's the only part we have to figure out. On B part, 40 years times 12 months in a year. Figure out how many months that would be. It would be 480 months. And then $200 a month times 480 payments. How much of that money did she put in herself? $96,000. So that's how much she deposited over 40 years. But she did not end up with $96,000. She ended up with $698,000. So she's made almost $600,000 in interest. Is that impressive? Should be. Yeah, I know. That's the thing. You want it right now. But you can have it in 40 years. Right? Yeah, so, yeah, I know. That's the thing. That's the thing. It takes time. But, okay, if you have the time, then you can get the money. So the idea when you're retirement planning is to end up with a number large enough when you're ready to retire that if you just take the interest for the next month, that's enough to live off of. So then you can be retired. In theory, you can be retired forever. Okay? But at some point, we're not going to need the money anymore. But that's the goal. That's the goal. And that number is different for different people. It depends on what lifestyle you want to live when you're retired and things like that. All right. Look at this next thing here. All right, this one I'll just do for you real quick. Okay, I won't make you run through all of it. Okay, it says we're going to do the same thing that we just did, except we're going to change the years. So we're going to say, what if she started at age 18? Started doing $200 a month at age 18. So then 65 minus 18 That'd be 47 years. 47 years. So if we go back to here, oops, sorry, change it to 47 years, what do we get? I'll punch it real quick. Not changing anything else, just the time. So just adding 7 more years on there, we were at about $700,000. We add 7 years on there, makes a big difference. And she ended up with $1,242,475.48. So 7 more years. Okay, so from instead of 40 to 47, but it's almost doubled the amount that it's worth. So that's why I'm trying to push on you best I can as a math teacher. Okay. I know it's not something on the front of your mind right now because you're all young. Okay. But try to start as early as you can. Okay. If not that you're worried about getting to a bigger number, at least you can make this number smaller. Okay. Retirement age. You can make that number smaller. So you don't want to have to work till you're 80. Okay. If you can help it. Okay. All right. Almost done. Almost done. Hang in there to get us out of Friday class, probably. One more formula. And one more formula. And the only thing that's happening on this one is it's flipped. Okay. So instead of R over E being on the bottom, it's on the top. Okay. The other thing we've done is we flip future value in the payment. Okay. So here what we're doing, we're figuring out how much will we have to pay into the investment account every month, okay, to end up with some amount of money in the future, given a certain interest rate, a certain amount of time. This is really what you want to know more. Right? How much do I have to pay every month to retire a millionaire? That kind of thing. Let's look at one of these. Formula's not any harder, it's just upside down. Let's look at one of them. Okay. Actually, let's skip this one. Okay. This one's just not as interesting. Let's go to the next one. We'll just do one more. Last one. Okay. So we're back to investing for college, but this time we haven't got an inheritance or something like that where we have a lump sum to invest. Instead, we're going to invest some money every month. So it says Amber wishes to deposit a fixed monthly amount into an annuity account for her child's college fund. We're still trying to get to $150,000 in 18 years. We just want to know how much a month it would take. And here it says assume APR 4%, so R 0.04, T is 18, our future value $150,000, and then we're making deposits monthly, so again it's 12. Okay. We want to know what the payment should be, what the monthly payment should be. Okay. So let's do that. So our payment will be our future value, $150,000, times, this time R over N's on the top, so 4%, N was 12, divided by 1 plus R over N, to the NT, which was 12 times 18, minus 1. What do you think? For 18 years, if you're going to deposit, if you're going to make a payment every month, how much is it going to take you to get $150,000? Anybody got a guess? You think it'd be a lot? Think it'd be more than a car payment? Think maybe? I don't know. Let's see. Let's see. So that's the kind of thoughts you actually have around. So I'm going to do the top first this time, 0.04 divided by 12, get that number. And I'm going to divide that by, got an extra parenthesis in there, 1 plus 0.04 over 12 to the 12 times 18 power. And then minus 1. All right, so there I get 0.003 something and times 150,000. Okay, there I get $475 and rounds to 30 cents. So I guess it depends on what kind of car you would buy. More than a car I would buy a payment, but not everybody. Okay. And then we had to be part. How much? We'll just do it in here. How much of it did Amber actually pay? I mean, how much of the $150,000 does Amber actually pay over the 18 years? All right, that's interesting. So we've got $475.30 is the monthly amount times 18 years is 216 months. So let's see, 475.30 times 216. She's actually paying $102,664.80. So essentially, paying for college, she saved like $43,000 because she started planning for it ahead of time. So remember, this is going to end up being $150,000. Okay. All right, questions? Calculator issues? All right, bring calculator Wednesday, especially if you didn't have it today. Okay? If you didn't get on the sign-in sheet, make sure you get on there before you leave.